This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you want to be part of the show, you can follow us on LinkedIn. You'll find us there at the National Fluid Power Association. And please be sure to share interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. If you see an interesting application of fluid power and you want to learn more about it, share it on social media with our hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to the show. You'll find us on all the popular podcatching services. Wherever you find us, subscribe, and then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. On today's show, I'm joined by Paul Michael, the director of the Fluid Power Institute at the Milwaukee School of Engineering. Paul is a longtime veteran in the fluid power industry. He's been involved in many projects, including standards development and a whole lot of research projects important to the industry. But on today's show, we're talking about a recent white paper that NFPA published and that Paul was instrumental in helping us produce, Preventing Leaks in Fluid Power Systems. We invited Paul into our forum today so we could take a closer look at some of the important points from that document. So, Paul, welcome to Fluid Power Forum.
Hi, Eric. Thanks for inviting me.
I'm excited to have you on the show. You've been in the fluid power industry for a long time, and this is your first appearance on Fluid Power Forum, right?
This is my first time, and yeah, I've been in fluid power a long time.
Yeah, tell our listeners a little bit more.
I've been going to NFPA meetings since about 1988 or 89.
That predates even me, Paul.
I've been working
You've been
in that
around.
area for quite a few years.
Well, tell our listeners a little bit more about yourself and your background. You're at MSOE now, but you weren't there all the time, were you? Has that been your whole career?
No, I was in the oil business for about 27 years, formulating and testing lubricants. My background, I'm educated in chemistry and business.
Mm-hmm.
That's my academic background. And I've been at Milwaukee School of Engineering for 21 years, focusing on testing fluids in hydraulic equipment, or testing hydraulic equipment in general.
Yeah.
So I've been in the lab for 49 years now, a long time. MSOE, we're a private university in downtown Milwaukee. We're 6 blocks from beautiful Lake Michigan.
Right.
We're 6 blocks from the Pfizer Forum.
Yeah.
And we're 6 miles from our friends at the National Fluid Power Association. And we've enjoyed a close relationship with NFPA for many years.
It's the headquarters of fluid power in a lot of ways, Milwaukee, Wisconsin. It's a great place to be. When did you start as the director of the Fluid Power Institute there at MSOE? How long have you been in that position?
I've been in this role for 4 years now.
And tell our listeners a little bit more about what that is, the Fluid Power Institute.
The Fluid Power Institute is it was founded in 1962. And its goal is to collaborate with industry and educate students in fluid power by providing hands-on experiences for learning in fluid power. So we have 4 laboratories. We've got a fluid power club. We have 4 fluid power labs. We have a fluid power club. We have the Fluid Power Action Challenge. We have a lot of fluid power things at the Milwaukee School of Engineering that's very exciting and interesting to work in.
And that's fairly unique, isn't it, Paul? I mean, you actually have undergraduate engineering students working hands-on with fluid power on behalf of industry, right? If I get that right?
Yeah,
right?
that's true.
Yeah.
That's true. Yes. And so they do get a lot of experience with fluid power that's quite unique through our university. It's one of our strengths, and we've been there since 1962. So
Right.
we actually, a lot of the leaders in fluid power graduated
Yeah.
in the industry, graduated from Milwaukee School of Engineering.
I meet many of them in my day-to-day life. Yes. Everybody seems to have a tie back to MSOE at some point. That's great. Well, we asked you on the show to learn more about you, of course, but also we wanted to talk about the white paper that you helped us produce on preventing leaks in fluid power systems, which we'll put a link in the show notes if people want to go check that out. They can certainly download that from our website. But I'm going to ask, maybe at a very high level to begin with, like, why do we have such a white paper? Is leak prevention really such a critical issue for fluid power? Well,
it is really critical for fluid power. There's in fluid power, hydraulic fluid is the power transmission medium.
Right.
And that power is transmitted through a pressure envelope. And one of the beauties of fluid power is its modularity. So we can take multiple components from various suppliers and locations and assemble a custom system that fits within the package that we need to fit it in and does the work that needs to be done. But we've got this fluid under pressure engaging the payload and working. And that puts a lot of stresses on the connectors and the fittings and the hoses and the tubes and the seals, and makes it vulnerable to potential leaks. So really, I think that it's important the fluid power industry to minimize leaks in order to maintain its reputation, to maintain its image, and to maintain its sustainability as a technology.
Yeah.
So I think it's one of the vulnerabilities of fluid power, but it's not something that can't be dealt with good engineering practices.
Right. And the white paper really helps the reader understand what some of those engineering practices are. But tell us a little bit more about the development of the report and some of you didn't do this alone, right? There was a lot of collaboration that took place.
We had a committee in the industrial committee, and I'd say there's around 25 people involved in the committee. And a critical thing that we did to start off with is we did a voice of the customer survey. NFPA likes to get the voice of the customer, and we asked the NFPA members and OEMs and other stakeholders, hey, are leaks a problem? And 75% of the surveyants said that leakage was a problem at their company. And we said, well, why is it a problem? And they identified 3 key issues: customer satisfaction, downtime, and warranty costs. And so those are things that are driving and having impact related to leakage that we want to help positively impact through this process, through the white paper.
So it's a big issue from the point of view of, as you just said, customer satisfaction and availability of the machinery, I'm assuming, right? So what are some of why? What are some of the causes of leakage in the system?
Well, according to our survey, the biggest source of leakages as far as components go are the adapters and connectors. Those things that make the fluid power systems modular. And the fluid that's right in the pressure envelope, it's where the fluid is transmitted through and connects to manifolds and pumps and cylinders and so on at those fittings. And so, those are the biggest problem as far as the survey goes, and something that needs to be paid attention to.
Are there other common causes, or is that really the single issue?
Well, no, there's a lot of causes. I think actually there were 31 individual causes identified. Gosh. And they can be going in different categories, like design, installation, mounting, selection, material compatibility. There's quite a number of different things that go into that problem, a challenge.
We'll continue with our guest in just a moment, but first I want to tell you about an opportunity to engage in the future of fluid power technology. Two of NFPA's most active committees are our two technology task forces, one focused on mobile applications of fluid power, the second on industrial applications. Each of these task forces work on a series of projects that help us better understand the technology trends in these sectors and help us develop the resources and connections that will be needed to keep fluid power positioned as an actuation technology of choice on both mobile and industrial platforms. The Mobile Task Force publishes a series of reports. Their latest was on ways to design more energy-efficient fluid power systems for mobile equipment with electrified prime movers. The Industrial Task Force also publishes reports. Their latest was on ways to minimize and prevent leaks in fluid power equipment. And they have also completed a year-long project that created an independent technology roadmap specifically for fluid power in industrial applications. All of these resources are accessible on our website at nfpa.com/technology reports. But more important is your ability to participate on and engage with the technology professionals that serve on these task forces. New working groups are forming now around the use of sensors and data analytics in fluid power systems, as well as many other cutting-edge technology advances. These task forces are a great example of NFPA's effective forum in action, with NFPA members across the supply chain and an increasing number of their OEM customers actively engaged in creating the technology strategies that help all of their businesses grow. To learn more and to get involved, contact me at elanke@nfpa.com. Right. Well, and the paper was designed to address those, right? So step one was to identify, but then step two is like, well, how do you prevent them from happening? How do you address these causes? So maybe we can talk a little bit about that. You know, one of the areas I know had to do with the design of the system itself. Can you talk a little bit more about like what some of the opportunities there are to design for leak prevention?
Well, the first thing you have to start off with is understand the application thoroughly.
Mm-hmm.
So you want to understand things like the accessibility of components, the operating temperatures, material compatibility questions, contamination, ease of assembly and maintenance, those kinds of things. What kind of an environment the equipment's going to be operating in, and what are the capabilities of the environment for supporting maintenance needs.
Mm-hmm.
So that's the first place you got to start. Then that design analysis drives your component selections. So you may select your ports and your connectors, whether or not you can use tubing or hoses, etc., based on the application factors that you've identified.
Mm-hmm. So it's a process of selecting the right components that will stand up to the rigor of the application that you're designing for?
That's right.
Yeah.
That's right.
Okay. So people who have heard me talk about this, I often say a well-designed and a well-maintained fluid power system, in fact, does not leak. So, Paul, let's take a look at the full life cycle then of the system, from this is the design as you're discussing, but all the way to the maintenance. Where do you think the greatest opportunity for reducing leakage is in that space? Where should we be focusing most of our attention?
That's a good question. I think that it's not an either or thing. You definitely want to have a good design, and some maintenance is required.
Sure.
But, the people that use fluid power equipment, they purchase that equipment and install it in their equipment because they have work to do. There's a job that machine is supposed to be performing. And they're focused more on the work product than on maintenance. They don't have the staff necessarily available to do all the maintenance tasks that are already presented to them.
Mm-hmm.
And so, from a fluid power standpoint, philosophically speaking, I think we should focus on coming up with the best designs possible to minimize maintenance and to help control that total cost of ownership,
Right.
and help the customers just focus on using the tools that we're providing to them and being profitable organizations by doing so.
Sure. And when you talk about the designing, the 4 best practices in leak prevention, the white paper references, and there are actually a lot of standards out there that can provide great information with regard to that. Can you talk about some of the most important standards to pay attention to in this space?
Yeah, there are a variety of SAE standards. The J517 hydraulic hose standard that defines the characteristics of the hose, its physical properties. And then, of course, you need to have performance. So there's a standard J343 or 6803 where they do impulse testing and burst testing and so on.
Right.
And they have specifications. So you've got one set of specification that describes the article and its physical characteristics. And then you have another specification that looks at the performance criteria, performance characteristics of the component. And so there's an alphabet soup out there of all the standards. Just a few of them really are listed in the white paper. I'd say we've got a page of standards in the white paper, and there's probably twice as many as those out there that define our hydraulic components and the performance requirements.
Well, there's a lot of, as you're saying, there's a lot of guidance, right, to make sure that we're doing these things correctly, right? These are not just things that people dashed off on a whim. These are documents that have been thoroughly discussed and tested for performance, right? So
that's right. And these documents are essential for that modularity that we have in fluid power. Having these standard designs and envelopes is what is necessary so that we can have these modular systems that can do all sorts of different things. Using a pump and some hoses and tubing and valves and reservoirs and filters and all the other components, put those together to get the job done exactly the way you need it.
Well, as we're describing, the report has a lot of do's in it, but it has some don'ts as well. I would one of the sections I can recall was about the use of tapered pipe threads, for an example. Maybe you can talk a little bit about that. Like, why is that not the best idea for these situations?
Tapered pipe threads they use what's called the interference fit, where basically you use torque and you have the interferences of two surfaces mated together that creates that sealing surface. And guess what? We have a bit of vibration in fluid power. Every time the piston goes in and out of the pump, it creates a micro vibration through the fluid.
Right.
And those vibrations can cause things to loosen. And if you have a pipe thread, that loosening will lead to leakage. If you have O-ring face seal or a JIC thread or one of the more modern threads where we have straight threads and solid connectors, you're not going to have that leak. So pipe threads are something to be avoided in fluid power system. Sometimes you can't get away from them because the filter housing or the reservoir or a flange or something that is required in the system only comes with a pipe thread.
Right.
But for the most part, you want to avoid those as much as possible.
Well, Paul, we're really just going over some of the highlights of this very informative document. And again, we would encourage people to go to the show notes and get the link to download it. Maybe as we wrap up here, where do you think the industry goes from here with regard to this? I mean, there's a need in the market for this kind of information to be actually applied. So, like, what should we be focusing on, and what do you think future improvement would look like in this area?
Well, the fluid power industry has come such a long way in one area, and that is in contamination control. We're really, really good at keeping the oil clean and filtering it. Anybody can buy a filter and assemble a system that's been engineered properly and keeps the fluid clean and eliminating those kinds of problems. A lot of that came through good standardization and education. Those are the key things to raise the performance of our industry in that contamination control area. I think the same approach can be applied to leaks. Continue to develop standards and test methods to qualify parts in terms of their ability to maintain the integrity in the system. And then educate NFPA members and its stakeholders on the proper use of these components. Their systems are designed not to leak.
Yep. All right. Very well said, Paul. And that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Paul Michael, who has been my guest on this episode. If you want to connect with him, you can do that by sending him an email, and we will put a link to his email address also in the show notes for this episode. And make sure to check out NFPA's full white paper on this topic. The show notes will have that link. Preventing Leaks in Fluid Power Systems is the name of the white paper. You can also go to our website, nfpa.com/technology reports, where you can access that and a lot of other resources for education in the fluid power industry. Remember, if you like our podcast, and we hope you do, please follow us on LinkedIn. You'll find us there at the National Fluid Power Association. And please keep sharing those interesting and innovative uses of fluid power with our hashtag, #OnlyFluidPowerCan. We truly want to hear from you about the kind of topics we should be talking about on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.